Blast off. All right, the paper I just gave you, we're going to take some notes right now, and what I'd like you to do is to follow along with what I'm going to tell you. By Einstein. We are starting a new unit. I'm really excited about it. It's called Waves and Sound. So in the end, of course, we're going to know about waves and sound, but we're going to learn about some stuff that you have, like phones and music and that sort of thing. Kind of cool. We also are going to have a lot of activities, a lot of demos, a lot of lab that we're going to be doing. So a lot more hands-on stuff. But we have to start with waves and what are the parts and stuff like that. Now what's really nice is that in nature, there's only two kinds. So it makes it really easy for us to learn them. So on your paper, let's write down types of waves. And we're going to start out with this one called transverse. Wave. Now I actually have different colors that I'm going to use today, so if you'd like to do that, you can. There's colored pencils back there. Otherwise, you can just draw what I'm going to draw. So this is not all that easy, but give it a chance here. This is what it looks like.
Whoa, that's like some high tech.
Yeah.
I don't know if I can do that.
This is called transverse wave. Can you think of something out there that might be representative of something like this? Yeah.
Like when you're on hook to lights or like the monitor your heartbeat.
Yes, like a heart monitor. Yeah. Like a bike lock.
Yeah.
Okay, like the coiled bike lock when you pull it out. Nice. Okay.
Things that we can see could radio waves count.
Okay, now radio waves, we can't see them, right?
Yeah.
But they do have this shape, yeah.
Because you got AM and PM.
Yeah. I was fortunate to go to a preseason Packer game, and at the beginning there were some guys doing rope. Huh? You know when they go like that, right? Good luck.
Thank you. Don't tell me.
Water. Right? Lake Michigan has waves like this, don't they? Okay, first thing I'm going to do, I'm going to make a dashed line like this right down the middle of this wave. Like that. This bump. Ava, are you drawing this?
Huh?
You're drawing this right now on your paper. This one right here. This bump is called a crest. This, oh, by the way, have you heard like you go over the crest of the hill? Right? Okay, and this is called a trough. Where have you heard the word trough?
Is there like forces, something like that?
Like what?
Something you feed a horse in or something.
Yeah, you put the food in the trough, right? Or maybe these are the things on your house, the trough that catches the water. All right, the reason why we drew this green dashed line here is because from here to the middle, or from the middle to the bottom of the bump, is called the same as if we were pulling a pendulum up a little higher each time. Anybody remember that fancy word? Amplitude. Nice. Now this is not a wave. This is waves. So now the question is, what is a wave? One wave length. Now we get tired of writing out the word wavelength all the time, so we have a symbol for it, and it's called lambda. Okay, let me draw it again so that you know how to write it. It's an upside down Y. You make a curve like that, and then another one there. Like that.
Can you do
Like
like
a T.
like so you stand on that side?
And like,
That looks like a T.
I'm ambidextrous today, see? Okay, how do you do it? This is real easy. All you do is you measure from one crest to the next. And that's called a wave length. That's one wave. So how many waves do I have here? I have 1, 2, 3 waves in the picture. Because I can do this. You don't have to do this. So there's your 3 waves. Okay? That's the first wave. Let's do the next one. It's called longitudinal. Okay, this one's harder to draw, so watch, here we go. Oops. So it is close together, far apart. Close together, far apart. Close together, far apart. This is an example of sound. So let's talk about that for a moment. So here I am. I'm talking to you right now, right? And the sound is doing this, which is then heading towards Nick's ear. And his eardrum now does this. Now his eardrum starts hitting the bones on the other side called ear bones. And they start doing this. And then the ear bones are going to hit this ball of fluid called a cochlea. It's going to be hitting it like this. And then you can hear it. Isn't that crazy? All that just for you to hear me, Nick, right? Here's this sound going like this, going to his eardrum, hitting the bones going, now I can hear it. That's crazy. Now what's here? Like what's between me and him? What's air, okay? Now if we go into space, is this here? No. So this is what it would sound like in space. What? Exactly.
Donkey Kong.
Because the sound cannot travel through nothing. It has to go through something. And the something is air, or liquid, or solid. It has to go through something, okay? All right, you got words. all this stuff right here that's together, they call that compression. Now, I was watching Avengers, Incredible Hulk, and he took something and he went with his hands. And that's compressing. Compress means to push together. They're together. Okay, over here, this part. That's called a rarefaction. So if you can see the wave, it goes compression, rarefaction, compression. In other words, close together, far apart, close together, far apart, close together, far apart. And we're going to do this today. Okay, who's got a question?